Going on, boat fam? So I'm gonna make a little video here today. Last time we ran this at my local park pond, if you noticed, I hit a stick and we broke the breakaway screw on the back of the rudder, and we put a pretty gnarly dent in this Mondo turn fin here, which I also didn't like the twin, or the two screw Z style strut, because it kind of kicked it at an angle. It would be just a little bit offset this way from clamping force only on one side. So I didn't like that. So what we've got is, this is strut kit from Offshore Electric. Here's the mount. And I can't get it any further on the stuffing tube. Not really sure about cutting the stuffing tube. Kind of afraid to do that since it's kind of glued in there. But I've got it pushed in there about an inch. So it's in there pretty far. My dilemma is this right here, because the screw hole doesn't line up. I have to bring it out to here, which puts a little gap behind it, and what I need is a 6 mil spacer. So I could, and I might, use like 2 layers of carbon fiber and just build a plate to go on the back of the transom and kind of just step it out. That will actually get the strut out a little bit further. It'll keep the prop away from ever contacting that. It'll also be the same exact distance for this, so it makes my flex cable perfect length too. So that's kind of what I'm planning to do for the rear of this thing. Another thing is, Big B was talking about a month ago, the motor that he got from his speedrun.com record. It was, I believe it was maybe an SVM. I believe it was this exact motor right here. It was an SVM. Mine is a 2130 kV. I don't know if he's got the 2380 kV, but I had made mention to him in the comment section. I said, hey, let's do like some fun, back and forth videos, since we both have similar SVM motors. I was like, why don't we you put yours in your rigger, I'll put mine in my rigger, and then we'll kind of go do some back and forth videos on that. Not sure if he's going to want to do that or not, but I'm going to do it. I'm going to put this motor in this boat, because this is a metal wrapped rotor. Totally an 8S capable motor here, but we got a little bit higher kV value, and due to the low hydrodynamic drag of this motor, or of this boat, I don't think we're going to have to worry about so much heat being built up in this motor. But I'll still have to watch it, because it is metal wrapped rotor. I cooked this motor the very first time I took it out, overheated it, never knew anything about it, but I learned the hard way. And when I had to get a replacement rotor for it, they only sold an 8mm shaft. So this will be the first time I've ever run any motor with an 8mm shaft. So that's the plan. We're going to drop this, which I believe it's a 4092, right? It's not a 4082. So we get a little bit longer motor, and I'm going to be working on getting the right spacing for this. And we're just going to do a little bit of upgrade. So we'll have a new strut, we'll have a new turn fin, and we'll have a different motor, and we'll just see how it goes. Cool. All right, first things first, I opted not to do carbon. I went outside, I was doing some measurements, and I needed a smidge over 6 mil. So that was either going to require me to glue 3 pieces of carbon together, or 2 pieces of aluminum. And to me, weight savings, aluminum versus carbon on something so small, it's minuscule. So it really doesn't bother me. If we line up our holes, which they look good there, then we'll take our piece here. And I'm actually using the camera right now as a way to give me some light. But everything seems to look copacetic there. Let's go ahead and pop it on the back of this. I'm going to go ahead and, bada bing, bada boom. Just hold it there. Let's see if the hole lines up. Spectacular. That's flipping awesome, man. Okay. So now I got to hold all this apparatus together. What I think I'm going to do is I'm actually going to go ahead and not mount it on the boat right now. I'm going to use 4 screws and 4 nuts, and we're going to tighten this all together. And then I'm going to, right before I tighten it, I'm going to put a daub of super glue here and a daub of super glue there, and then I'm going to tighten all 4 bolts. That should make this all one piece. That way when I pick it up as one piece, I can put it on the back of the transom, and then I can mark my holes. These 2 holes luckily line up. I just have to drill 2 holes over here. I just need the super glue to hold it, you know, as far as like making my template. So let's go ahead, we'll put this on there and we'll tighten the bolts. We'll give it 30 minutes to dry, and then we'll start the process of mounting it on the transom. All right, we got our screws going in. We've got the hole drilled so tight it's basically cutting threads into the wood. We're still going to put a nut and a washer on the back side of it. But that's what we got. We got just enough. You can tell I put some shoe goo in the other 2 holes since they were a little bit larger, but it shouldn't matter. I went ahead and checked to make sure it was dead nuts level with the micrometer, and I think we're good. And that's perfect. Our hole lines up, our spacer works perfectly, and it's the same length as the old strut, so we're golden. And now with about 30 or 45 minutes worth of frustrations and a couple of solder joints, I went ahead and converted the 8mm bullets that I had on here to 5.5mm bullets because that's the way the 10-shock motor was set up. And I already had these leads. The only reason that was like kind of screwy was because these stock leads on this SVM motor were literally like 4mm too short to get it to go into those bullet connectors, so I had to jump them, which was a little frustrating. But I got them in there, got the motor all in, TFL cooling jacket on, got the 8mm coupler on, blue Loctite on the grub screws, so we're good there. This is all done. Let's go ahead and grab the shaft. See if this big old flimsy thing will go in there. Okay. Alright, that's bottomed out. Bottomed out in the motor. Looks like the perfect gap. Heck yeah. Okay. So we've got all of the essential running gear done. The rear's good. Got the rudder fixed. I don't have a brass breakaway. I just had to put a regular screw in it. But I've just got this kind of chilling right now on the ski. So hopefully that's the right angle, but it's kind of level with the top. Can't go no deeper, but it can come up. But I tested the spin of it earlier. It spins pretty free. And unlike the dog leg thing here, it's not gonna cock at an angle, which I think that angle that it was putting it under was causing my cable to have that awful rattle noise, you know, because if it's under the slightest kink here, then it's going to kind of give it that snake effect going all the way up. And I think that's kind of what we were getting. But, okay, now the only thing I really got to do is fabricate a straight aluminum turn pin. Alright, we're out here in my garage, and we're going to take this turn pin and we're going to see if we can try to manipulate some aluminum, which I think this may be perfect. I think it's honestly similar size and thickness. I think we can work with this. Maybe a little bit thinner. Hell yeah. Okay. Let's go ahead and draw out a template. Okay, so it looks like this upper section here we can use. It doesn't have any bends in it, so that's what we're going to do. If we go like so, we can utilize those two corner pieces. And then if we roll this down like this, that'll tell us kind of like maximum bottom. We don't want it to be any longer than that. But it doesn't even really need to be that long, because the bottom of it theoretically is about right here. So what I'm opting to do is split the difference. Let's just add another 1/2 inch right there like so. That will be our bottom. Then we'll go ahead and cut this to that point, and we'll come down to here, and we'll carry the contour here in the front like so. Okay, we'll use our straight edge here to continue our line. All this really won't matter. This is just kind of giving me a line to follow on my bandsaw. I'll go this way with it, and then we can go ahead and do a nice little curve here like so. And then once we get this cut out, then we'll take it to the sander and we'll sand the edges and get this thing to look like a nice straight fin. Okay, gotta get hearing protection. I've been working a lot on my go-kart lately. If y'all want to see that content, let me know and I'll start making content on it. But these two tools right here are like a must-have for this hobby. All right, let's see what we can do. All right, we're gonna cut it this way first, and then we'll cut it the other way. Okay, this is our rough shape. I'm gonna go ahead dress it up with the belt sander and the disc sander, and we'll see what it comes out to be, and then we'll lay the other fin on it and we'll pop our holes with the drill press. Oh, damn static electricity. Shit. It's not fun. I'm not having fun. Okay. I think that's good enough for just a rough, and we'll go ahead and pop some holes in it, and I'll sand it by hand to really doctor it up. I think it'd be a smart decision to put a leather glove on in this situation, just in case that sharp piece of aluminum wants to bite into the drill bit. Doesn't whack my hand off. Now that we're back inside, I've started to kind of work on it. You can kind of see the direction I'm sanding it, trying to keep the direction of the water flow and the direction of my sandpaper kind of going in the same direction. Got a pretty nice edge on it right now. I don't really know if I want to go too much more than that, or it'll start becoming risky to my hand. I decided to kind of smooth the back over. I thought about leaving it blunt so the water would break off of it, but it had too much of a, I guess, an edge from cutting it. It just made more sense to round the back of it as well. But use some 320 on it. I'm going to go ahead. I've got some 800. I'm going to dress up the edge with that, and then we're going to mount it on the boat and see what it looks like. All right, well, the final step of the process is I went on the Castle link. I actually used the B-Link on my phone, and it threw it into some weird thing. So if you ever have a uncontrolled amount of beeps and a frustrating amount of time trying to figure out why it's not working, you have to use this little connector, okay? And you have to use this. You cannot reset the Xlx2 back to factory settings using the B-Link on your cell phone. So basically what you do is you go down here to the corner and it says set all settings back to factory default. I had to do that, upload it, it was good. Then I went back into it and I basically adjusted the timing to 0. And then the punch down to 30%, and my reverse at 25%, so on and so forth. So now I went ahead and pulled the shaft out of the collet, but now it works. So we're good there. I just threw a little 4S pack on there just for shits and giggles. But I think what I really want to do, I might end up pulling this Velcro out and then just start using jam foam and a buttload of tape, because I think I can actually fit 4 different batteries in here if I stop trying to lock it down permanently with Velcro. It's just not enough room. Me personally speaking, based on this versus the Oxidine Outrigger, I prefer the Oxidine Outrigger. Even though I own this, I don't even own the Oxidine. I like the way that the Oxidine, you know, the Oxydigger, whether it's in the carbon or the wood version, I like it that the motor's in the back and the battery's in the front. Just seems to be a more legitimate way of doing it, but I don't know. That's just me personally. But this is going to be cool. SVM 2130 kV. And I was really hoping to put the run video in with this, but I just didn't have time today. I had to do the turn fin. Turn fin turned out really nice. I went ahead and sanded it all the way down to 2000 grit, and I used my Dremel with a polishing wheel right here, and I polished the shit out of the aluminum turn fin. So I think it actually turned out pretty nice. You can kind of see some of the polishing scuffs on it if you catch the light right, but she is like super smooth right now, so she's kind of waxed out. And when I took that spill at the lake, I think it slid this off, so I went ahead and put a little dab of super glue on it, and residue of the super glue kind of got on it. Now, one thing I did do, I went in the data logging, and it showed me during the last run, if you go back and look, I was curious if I had hit 100% throttle, and I in fact did hit 100% throttle. Even with this 4518 prop, it did on average 160 amps with the 10-shock motor. It had a peak amp of 206. That was one like split second peak, but I had 5 other hits of like full throttle. I think it was like 97% throttle or 96% throttle, and they were 156 amps, and that was 4 of them, and then one of them jumped up to the 206. That may have been the moment where I was like under full throttle and actually hit that stick. I don't know, but it was just a little quick jump. But all the other tall spikes on the graph were only in the like 150, 160 range. So I just think I didn't have a big enough prop for the 1750 kV motor. I think this boat right here will absolutely be a rocket ship if I had like a 2400 kV 4082 or maybe a 4092. I don't know, but we'll see. 10-shock motor, expensive, high price. I just wanted to try one of the heavy duty motors. I think I was talking to Garrett Brasher about it, and he says they're good motors. They just need to be set perfectly, and I'm kind of in line with that. But for now, I think I'm just going to stick between like TP motors, Triple S motors, and Leopard motors. They seem to be a good bang for the buck, and you know, is what it is. But I've gotten this all done. I'm happy with it. I'm going to rip out the center Velcro, and then we'll try some bigger batteries. And then the next video, I'm going to take this out in the pond and we'll give her a rip. So hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, and we'll see y'all out at the pond later. Peace.